Hi, it's Terry Dennery of the MathWorks. So in this video, we're going to bring the robot mechanics, its design, into Simulink, and that will be the basis of a very useful simulation mechanical model. All right, so here we are in SolidWorks, and so it begins by really bringing this into SimWise. Let's bring SimWise up there. We will open up, we're in that same directory, robot SWs for SolidWorks. That's a model we've already built. We're going to create a new one. All right, and we're going to open directly the SolidWorks assembly. So I show sld.asm files, and there it is right there. So let's double click on that. Okay, so a little bit of processing going on. You know, what's good is we're going to get kind of the robot. We're also going to get a list of the assembly, and we're going to maintain the assembly structure with all these sub-assemblies that were originated inside SolidWorks. So you'll see, you know, there's a little bit of depth to them before we get to like certain bodies and stuff like that. Okay, so anyways, I'd like to just continue to hit the run button when I build these models. Okay, large forces. Okay, right. I thought I'd fix this, but I know it's a materials issue, so I'm gonna just kind of fix the material issue just right off the bat. And it may come, and certainly throw questions with comments on how you would want to kind of make sure you preserve materials. But I certainly like the degree of material control that we have inside SimWise. You'll see a list of materials, and I'll choose just to make the whole thing out of aluminum, and perhaps we'll have, again, a later video where we get into detail and we'll differentiate a little bit more. But let's go ahead and click on OK. Close. Try running that again, and now yeah, it runs without issue. All right, so not a big deal, and certainly materials are important. And again, we'll just keep on going. All right, so the basic idea, I'd say bringing this in there, the other thing I'll talk about is, well, it came in up, you know, vertical, and now it's horizontal in SimWise, but notice what direction Y is there in SolidWorks. So what's really maintaining is, you know, X, Y, Z. And for various reasons, you know, there are a group of people who like to think of Y as up, and there's a group of people who like to think of Z as up. And so we're just going to have to handle that a little bit. So anyways, but I kind of like it horizontal when I build the model. So maybe you'll see why as we go through this. So again, here's where we are. We kind of run this, and we just see it falling freely due to gravity. And so I want to take this part right here, and you'll see it real clearly in a second, but I want to fix it. And that's essentially the main fixture to the ground, right? And you'll see it clearly because it's going to stay and everything else is going. All right. So now I want to just essentially, you know, get our joints in, and our joints, most of them are going to be motors. And so, right. And so let's put our first motor in. All right. And so I want to focus in here. I want to take that part, I want to connect it to this. This could be kind of a key piece in what we call the turntable. All right, and so if I hide that, I can see that surface real well. You also notice that it sees circles real well, which are highlighted in blue. It means that when the mouse recognizes it and shows the image we're seeing right now, I click, it places that coordinate system, that local coordinate system at the center of that circle. I'm going to rotate this a little bit just so you can see that it also places it so that Z kind of points out. And so you can see the local Z's that way, the world Z's that way, so there's a rotation, all that kind of stuff. Anyways, it's just going to keep on going with it. And so what I want to do now is from the object list, I can kind of see in fainted yellow the part that's hidden. And so I want both that chord and that part that's hidden selected. And then I bring up this create constraint dialog. And you know, we'll kind of get into this a little bit, but basically we have enough information to create our joint. I'll create a revolute joint. A revolute joint is like a hinge. And let's bring that part back like that. And let's hit the I on my keyboard, gives me this isometric view, and I hit run. And so that's what we got now. I kind of like this wait for it, and it ultimately will tip over. All right. Okay. So as I said there, I think I mentioned there are about 55 parts that make up this assembly. All right. And this video, we should be able to do this. If I do this well, we'll do it in like 20 minutes. So that means that we're getting a lot done very rapidly. All right, and so here's one of the key things that makes things happen quickly. All right, so if I click on that subassembly, I see like these whatever 10 parts that make up that subassembly. Well, I can also very quickly just say, hey, all those are in an assembly for a reason. They do move together. Let's just rigidly join them right now. You know, we kind of see it all moving like that. All right. And just if that looks confusing, let's bring the rest of the robot back. So show all. And that's where we are right now. Okay. So the basic idea of this is to put in these constraints that are going to allow, I'll call the actuation, and this will be our first motor. I think I've been calling it TT motor. All right. Still functionally a revolute joint. So we'll go into this dialog here, and with its rotation already defined, we'll just go to there and choose it to be a revolute motor now. Okay, and with that, I think the default on this is set it up at rotating at 90 degrees per second. The key for us is that when we bring it into, it's almost like we created a tag and said, treat this thing special, because when we bring it into Simulink, it will be a motor. We will control torque and even hook up electric motors and control voltage to make these things move. So, anyways, we're moving pretty well. So let's go do the next one. Right. So next one, I'm going to hide that piece. All right. So that piece is part of the bicep subassembly. And again, I kind of like hiding it so I get a nice view of the circular edges. And circular edges will become blue very quickly, and we can very quickly attach a coordinate frame right to their center. All right. So this time when I create the constraint, I'm going to be a little bit more elaborate. Okay. So first of all, these are all the joint types that we can do, and it includes ropes and you could say springs, well, ropes and strings and rods and belts and all kinds of things. So superb, I'll say, facility of types of joints we can make. All right, and so with regard to what's really happening in a joint is, well, it's bringing two parts together, but it's also bringing two parts together at a very specific location. And so we mark those specific locations with the coordinate frames. Those coordinate frames really do have a, I'll say, possession, that they're possessed by the part that they're connected to. We kind of see that in, let's see, well, this is the horn. See the little plus sign right there, and there's the coordinate frame right there. We'll also notice that when I hit run, it just kind of sticks with it, so that's good too. All right, and now let's go get it kind of getting set up for the creating the constraint. All right, and so what I want to get at is this idea that, well, there are four things that we need to know to create a joint. That's why these four fields are there. All right, but we only selected two. All right, well, we selected that coordinate frame, and that coordinate frame knows it's on this piece called the servo horn plastic. So that's where an automatic fill is taking place for us. Now, the other thing selected was ASB 10.2. And so notice here, well, what's going to essentially mark the location for that part? Well, that part already is, I mean, it's hidden right now, but it's already where it needs to be. And therefore, the coordinate frame that we need to attach to it, well, it kind of knows where it needs to be too, because it needs to be exactly where the other coordinate frame is. So a new chord is created, and it's kind of located in that same place. Anyways, just kind of a cool feature, and probably won't go into such detail too much further in the rest of this video. Let's just kind of operationally kind of put the rest of the model together. All right, and so this will be the bicep motor. Okay, and we will convert that to a motor as well. Okay, now I'm going to be kind of quiet. I might speed this up in editing, but I'm going to pretty much do the same thing that we've done so far and put the rest of this assembly together. All right, and so rigidly join that assembly. Directly create a revolute motor this time. Four-arm motor. Before I do that, click on this part and see that that's part of the forearm. It's part of the wrist. Proceeding quite well here. Pretty much since everything's rigid in the, or will be for the hand assembly, we can choose any one of these parts. I'm kind of choosing this one based on where the dashed outline is. And we'll finish with these last two pieces. These are both assemblies, and these will be welded to the hand. And these will be rigid joints, often called welds, too. Giving it the name gripper motor because we may come back and convert that into a motor, and it will be pretty easy to do, or easier to do. And then rigidly join the gripper. And now all we got left is that gear. Kind of randomly choose that part, and that this will be a weld joint too. And I'll call that a gear motor too, leaving ourselves the option to actually implement the torque that will rotate the hand via the way it's really done here with the motor and the gear. Right. With that, we got the whole robot done. Okay, and so we'll finish this video. We'll kind of orient it. And so we'll just come back to our original piece right here, right? I'll go to position. Now, I could go and kind of in my head try to figure that out in radians, but I kind of prefer degrees for this sort of thing. So I'll just go here to units, and we will choose everything to be SI degrees. "90, isometric, and we're vertical again. Now, is it moving the way we want it to? No. And that's why we need to bring it to Simulink, where we can design missions and implement controls. We'll make it work. And so let's just kind of finish this up by importing it into Simulink. I'll save it into this folder where I've been including all the files for the demos we're doing, and just called video demo. So I just emptied it out. And so let's give this the name robot video. All right. Okay, and so now let's just bring it into Simulink. We do that with get geometry, which is designed to work with SimWise. That's why SimWise is showing up there. So we just go ahead and import. And it's going to import the active document, the document that we just created. And it's got that name robot video right there. Let's just hit run. And basically we just did this. We did all this in just about 20 minutes. Thank you.